liftoff. Go Super Heavy. Go Starship. Thanks for all the historic flights, Pad 1.
Vehicles pitching downrange. Booster Raptor chamber pressure nominal.
Booster and ship, nominal power and telemetry.
All right, we are about 45 seconds into flight. We're still getting the rattle here at Star Factory. We are seeing 33 out of 33 Raptor engines lit on Super Heavy as it arcs across the Gulf. Coming up next on Max Q.
Max
All right,
Q.
So at this point, we've passed through that period of maximum aerodynamic pressure. The next thing we're looking forward to is going to be hot staging. So we've got 33 out of 33 Raptors lit. Super Heavy makes its way uphill. Hot staging is going to be coming up in just a little over a minute. At that point, we're going to see all but 3 of those Raptor engines on Super Heavy shut down. Our version of MECO. Most engines cut off instead of main engine. And then after that, we're going to release the clamps that are currently holding Starship to that hot stage adapter. It's then going to ignite its 6 Raptor engines to push it away from Super Heavy and then start making its flight uphill. So in about 30 seconds, we're going to see the engines start to shut down on Super Heavy. You'll see them kind of shut off in separate banks until we've just got those 3 center engines that never stop running for this process, and then looking for 6 ship Raptors. All right. MECO coming up in about 10 seconds. See the engines throttling down.
Booster engine cutoff. Ship ignition.
Stage separation.
Use backburn startup.
All right, successful hot staging maneuver. So we've got 12 of the 13 engines lit back up on boosters, so it's doing its boost back. Real excitingly,
Ship
though,
chamber
we've got
pressure's
6
nominal.
out of 6 Raptors lit on ship there, so it's now going to continue to make its ascent into outer space. Meanwhile, this boost back is happening. We're using those 13 engines, so everything, well, 12 out of the 13, and then we go down to 3, and then we're going to shut down for the end of boost back. That's sending Super Heavy back towards its planned splashdown zone in the Gulf. Right after we finish this boost back burn, we're also going to separate the hot stage. This will be the final time that we're doing this. All right, there's the end of the boost back burn. We should be seeing the hot stage. There. So the hot stage separates. It's going to make its way down, also splash down in the Gulf. In the meantime, though, these 6 ship Raptors are going to continue firing for about 5 more minutes. Next up for the booster, though, is going to be its landing burn. There's a cool tracking shot. We dumped some of the prop out on our way back in. All right, so for booster, this is one of the main things we're trying to get is going to be this landing burn. Oh, that's so you can see the hot stage kind of making its way towards the left side. So that's the bottom of the booster. It's about to pass right in front of where you can see some of that prop dump happening. They look like they're close together, but there's a good amount of distance between them, and the hot stage will go down and splash down in the Gulf while the booster comes back for its landing burn.
Starship is on nominal trajectory.
All right. Looking good on our trajectory, looking good on everything. Jake and Amanda, you guys with me down there?
Yeah, definitely. The crowd is gathering over here in the office. You can definitely feel the energy in here. Great to see that booster is making its way down to the splashdown zone in the Gulf.
Yeah, the shaking down here was absolutely nuts. The windows are still there, still intact. So that was pretty awesome. But yeah, booster's coming down. We're at about 30 kilometers. All right, yeah, and as we approach that landing, just like tower catches, we will be doing a 13-engine landing burn to slow down. This time it will be in a V3 configuration. And as we're starting to get into the denser part of the atmosphere, the booster is using 4 hypersonic grid fins to guide itself through atmospheric entry towards its landing site.
And we're just about 20 seconds away from landing burn start, where we'll first ignite the center 13 engines, then bring that down to 5 to slow down the booster for landing. And finally, that will come down to 3, and we'll cut all of them off while we're still about 200 meters in the air. So booster is going to see a bit of a harder landing.
Booster landing burn startup. Booster landing burn shutdown.
And there we heard it, booster landing burn shutdown. We saw a 13 to 5 to 3 V3 demonstration, and into the water we go. Wow, that was absolutely awesome. If you can even hear us right now, congrats to the whole SpaceX team. So far, so good for today. That was incredible.
All right, great stuff, guys. I'm jealous of the crowd. All right, back to ship. Ship's still making its way. We've got a little under 2 minutes left in this ascent burn, so we've got all 6 Raptor engines still firing. So the next major milestone we're going to be looking for is SECO. That's our second stage engine cutoff. That's should be coming right at about 8 minutes and 58 seconds into flight, so we've got about 1:20 still to go. Really cool to see booster go through that landing burn. That was one of our really key demonstrations we wanted to try and do today. That's mimicking what we're going to be hopefully doing. Oh, we just got our sonic boom, sounds like, from the booster coming back. All right, less than a minute to go. So we are going to see the 3 RVACs, the vacuum optimized engines, shut down first, and then we'll shut down those 3 center engines. So we should be a little under a minute until SECO. Just a reminder, this is putting us into a suborbital trajectory, so we're intentionally just going slow enough that we're not going to achieve full orbit. This puts us on a course where those engines shut off, and no matter what, we're coming back.
Starship is in terminal guidance.
In the Indian Ocean. All right, terminal guidance. So we should start seeing the shutdowns come up in just a couple seconds. Less than 30 seconds to go in this ship ascent burn. All right, RVACs have shut off. 3 more to go.
Ship engine cutoff.
All right. All ship Raptors have shut down.
Nominal orbit insertion.
You just heard nominal orbital insertion, so we are on the path that we wanted to be. So we've got a ship back in space, a whole lot planned for it, lots more still to come. Great seeing Super Heavy make its way to the water, but I'm excited to see what ship can do in space. How's everybody doing down there?
Yeah, if you could hear the crowd behind us this whole time, people are definitely happy with how the day's been panning out so far. Definitely exciting to see Starship safely in space, and super pumped to see all the team's hard work in action here today.
Yeah, and we guaranteed it at the start of the show, but it has been an awesome day so far. It's crazy. All this has happened in just 10 minutes. All the objectives were met on the booster, including that V3 style landing burn. So now all eyes are on the ship as we get ready for our in-space objectives. But we've got a few minutes until that next milestone, so sit tight, enjoy the views, enjoy the space jams. We'll be back at T plus 16 minutes for payload deploy.
welcome back, everybody. If you're just now joining us, where the heck were you? But we are getting ready for payload deploy. That's going to start once we get the payload door open. That should be happening, or at least starting, within the next minute or so. It's been a really cool flight so far. Quick look inside the payload. We've got 8 Starlink simulators getting ready to make their way into outer space. But great flight so far. Booster able to make it all the way to its splashdown and landing burn experiment, so that was really exciting to see. We got ship on orbit, nominal orbital insertion, so right on the money with its trajectory. And now we're ready to start tackling a couple of in-space objectives. So next up, we are currently venting down the nose cone, essentially the payload area of Starship, as we get ready to open up this payload door. We were able to do this successfully for the very first time on our last flight, on Flight 10. Oop. Hal got ahead of me. Looks like he's opening up the payload door already. All right, looks like we got the door open. All right, so payload door is open. Next up, going to be to start deploying these Starlink simulators. They are roughly the same size as the V3 Starlink satellites that Starship's going to be carrying. That's going to add some pretty crazy capacity. We'll run through the numbers in a little bit. We were able to do this for the very first time ever on our last flight, and so this will be another test. We made a couple of tweaks to the rails for deploying this based off of what we saw last time, but excited to see these get out the door. Our next iteration of Starship's also going to have kind of a more powerful PEZ. It's going to deploy these at a little bit faster speed, but looking to see our next demonstration of this hopefully in the next couple of seconds. We should start seeing them move out the door. I mean, that view on your left, so you're basically, that would be if you were sitting at the very top of the nose cone looking down. So there's kind of a short stack. There's 4 on either side, so 8 total. When we start flying Starlinks, for their actual deploy missions, we're going to be carrying stacks of about 60. So much larger stack once we start flying these operationally, but still doing a little bit of a short just for this payload deployed today.
Looks like we got a little bit of movement there, Dan.
Coax it out. Get it moving, Jake.
There we go. All right, first one going out. All right, first one's deployed. Getting ready for the second one here. We do a little reset back to the center position.
Yeah, it takes about a minute for each one.
Looks real smooth too. They made a couple of tweaks to those rails. If you watched the last ones, it had a couple of bumps on the way out, but moving out super clean this time.
Yeah, and as noted earlier in the show, but definitely worth repeating, Starship will deploy Starlink's more advanced V3 satellites, adding 60 terabits per second of capacity to the network per launch. So that's 20 times more than each Falcon 9 launch does today. Just incredible.
Yeah, and anybody that's been following Starship, you know Starlink's kind of the MVP for these flight tests, where it's not only giving us the views we're seeing right now, but also just real-time data through every phase of flight. So We've got a couple dozen cameras on Starship. We've also got a bunch of cameras spread across the globe, including out in the Indian Ocean where we've got our fun buoys floating. There goes another one. And I mean, we're using Starlink to bring all of this together. It's our drone shots you see here from our great team down here at Starbase, all connected. So Starlink not only giving us cool views off the planet, but also on the planet, help bring everybody along for all these Starship flights. I think that's number 4. Somebody check my math. Okay, we've got 4 Starlink terminals on the outside of Starship. He uses that to talk to the constellation, and through that we actually get about 120 megabits of bandwidth for our downlink. That's our real-time HD video, all of our telemetry. So it's not just kind of giving us these cool views inside, but it's giving all that engineering data in real time, including re-entry when normally a plasma layer builds up and blocks you out. Starlink, powerful enough of a frequency that we're able to kind of punch through that and still get that live view. All right, next one out the door. There we go.
All right, yeah, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of who have never had connectivity before. Oh. Right. Today, Starlink serves more than 150 countries, territories, and other markets, with over 7 million active customers and counting. To meet the global growing demand for high-speed internet, SpaceX expanded its factory over in Bastrop, Texas, which is just outside of Austin, and also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard Kit.
Yeah, and one thing to note about the satellite deploy is that they will be following the same suborbital trajectory of the ship. So these dummy sats will not be going in orbit. We do expect them to burn up on re-entry.
All right, couple more to go. I promise one of these days we'll deploy in daylight. But we're basically trading deploy in the dark so we get those re-entry views for the daytime. All right, I think we got one more to go.
All right, now with payload deploy complete, Starship will now close its payload door and continue to coast around Earth to the Indian Ocean. We still have a ton of major events to come today, including Raptor relight at about T plus 37 minutes. That will be followed by atmospheric reentry and splashdown. So with that, we're going to go on another quick coast.
Yeah, if you can hear us.
All right, with that payload door closed, we're going to sit tight, enjoy the views, and enjoy the space jams. Again, we'll be back in just a few minutes for Raptor relay, and then head back for reentry. right, welcome back everyone. If you're just joining us, you did miss some exciting stuff because Starship successfully deployed its second ever payload, 8 Starlink simulator satellites. And now we're expecting the relight of a single sea-level Raptor engine in space coming up here just after T plus 37 minutes. So about a minute left to go.
Yep, just a little while. I think we're tracking to 37 in around 49 seconds or so. So we should be just about a minute and a half where, again, as Amanda just said, we're going to relight one of those center engines. This will be the third time that we've tried this. We did it successfully back on Flight 10, and then we did it for the very first time back on Flight 6. This is not a deorbit burn. This is demonstrating essentially all of the systems you would need to do a deorbit burn. So that's obviously your Raptor engine, and then also your header tanks, your smaller tanks in the nose cone, where we have liquid oxygen, liquid methane in a smaller, more easily pressurized container, which we can use for on-orbit burns. And we're also going to tap into those when we do our landing burn. So this will be a critical capability. Once we go to full orbital missions, you'll have to do a deorbit burn to break out of orbit, send it back down to Earth. But in this instance, we're already on our way back down towards Earth. So this is just going to demonstrate the capability of turning one of these engines on. We should be coming up in just about 20 seconds or so, looking for one of those Raptor engines to turn back on. They've been off since we completed that successful ascent burn almost 30 minutes ago. Here we go.
Oh, Raptor ignition. And shutdown.
All right, there was that Raptor relight. Looks like engine 3 full duration. As Dan mentioned, that's a third attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptor team. And then there we heard nominal second orbital insertion. All right, so congrats everyone on the milestone. That was awesome to see. We're 3 for 3. We're gonna take another break, and we'll be back for re-entry at about T plus 45 minutes. We'll see you soon.
Starship is slewing for entry. Starship is approaching entry interface.
Ship is starting entry, good attitude.
All right, welcome back, everyone. The ship is currently re-entering Earth's atmosphere. As a reminder, we don't plan to recover the spacecraft today, but rapid and reliable reusability is the ultimate goal.
Yeah, the light show has already begun. You can see plasma starting to build on the windward side of the rocket there. And, re-entry is a critical phase of flight, and we need information on how the ship's systems perform. Re-entry is also extremely demanding portion of flight because we need the ship to scrub off all of the energy we used to launch the rocket. So remember the 33 engines plus the 6 engines on ship that we used to get up into space, we now are using aerobraking essentially to scrub off all that energy. And of course, Starlink is a big part of this, giving us the views we have right now, and also letting us gather as much data as possible, which again is really the main reason why we do these flights. And the view we have right now is actually a really good example. As we mentioned at the beginning of the broadcast, we have some tiles on the leeward side of the flaps here, and we have some different mechanisms, some stud out, basically to see if these tiles will hang on. And we can see already here, it looks like we kept most of them, but I think I see a couple there that are no longer there, so the thermal team is definitely going to be digging into that and taking that data to help us iterate on V3. So yeah, Starlink provides us with one more path to collect data and help us rapidly iterate Starship's design.
And if the ship does manage to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or 5 miles per second. At those insanely high speeds, the spacecraft moving through the atmosphere creates a plasma field around the vehicle.
Yeah, and that blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. All right, so big picture here, Starship is designed to land on Mars where there are no runways or other humans to help out. So that means we need to do a propulsive landing instead of a more traditional means like parachutes, which is what our Dragon spacecraft uses, or a runway like the Space Shuttle. Propulsive landing enables more rapid reusability.
Now, as the ship makes its way back to Earth, we should start hearing some callouts. When we hear entry max heating and entry max Q, that means the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through all of those, that's a pretty good sign that we're doing well.
Yeah, and we heard flaps have control of the vehicle now. Okay, there's a great shot there. You're starting to see the plasma build up. So we will hear a call out when the ship is transonic and then subsonic. Transonic refers to the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, somewhere in the range of Mach 0.8 to 1.2. All right, a lot of numbers coming up here, but for reference, commercial jets have a range of cruising speeds, but most fly around Mach 0.74 to Mach 0.85, which is 480 to 575 miles per hour, or 770 to 930 kilometers per hour. Right now, we're going a little over 26,000 kilometers per hour. So compare that to the airplane at 930. It's like pretty crazy how fast we're going here. All right, and after we hear the call out that Starship is transonic, we should hear the call out that Starship is subsonic. Subsonic, of course, refers to the speed that is much less than the speed of sound. So at that point, the ship's velocity will be starting to slow down, and we'll be looking a little bit more like some of our suborbital flights from, at this point, almost 5 years ago.
Yeah, so re-entry so far is looking pretty good. You can see that plasma field. Also, again, with those missing tile experiments, especially, we're putting the ship through a lot today, but things are looking pretty good so far.
Yeah, we're looking good. I do want to remind people that we are pushing ship to the limits. We've done a lot of these missing tile tests. We did it back on Flight 10. Every time we do it, we throw something new and the ship makes it through. This time, we're really pushing it. We've removed these tiles in some of the spots that see the highest level of heating. And we remove tiles that have zero backup protection underneath. So there's essentially just bare steel. It's one of the heat of re-entry. And so do not be surprised if this is not a very smooth flight on the way down. But again, this is intentional. We are trying to find what are the limits for a ship. How resilient are we to these different issues that could pop up? If we lose a tile anywhere in the vehicle, we want to know what that ultimate impact is going to be. So we've got a couple missing. We had a bunch pulled over the primary fuel, the LOX tanks, everything. This one, we've got a tile missing right on top. So that's going to see some of the highest temperatures during this re-entry, and there's just bare steel right underneath it. So we're going to see if Starship's robust enough to pull through that. Also have some tiles missing around the aft flaps, specifically on the leading edge. So again, we're getting a really good look right at the leading edge. That's getting really intense heating. So again, gonna see if it can make it through. See if all the flaps hold on, see if Starship holds together. But definitely could be a bumpy ride, but this is why we're flying. This is why we're flying in this part of the world. This is why we're putting Starship through these flight tests to really understand what its limits are. So we can then move on to the next thing, which is going to be bringing ships back to the launch site for a catch. But for now, still on this suborbital, the light show continuing. Keep following it in. I think we got about 15 minutes until splashdown.
Yeah, Dan, and it looks, you can see our speed our speed indicator in the bottom left there. It looks like we're starting to scrub off velocity a little bit quicker.
Ship is entering the peak heating phase of flight.
Looks like we can see some clouds down there as we pass through 70 kilometers altitude.
Yeah, the sun's starting to come up again. Ooh, there we go.
There we go.
Skirt is intact so far this time. If you watched Flight 10, you saw we entered with a little bit missing. That was ultimately traced to a little bit of buildup. We dumped prop on the way. We had a little bit of solid propellant buildup, and then either static discharge or the plasma ignited it, took out a tiny bit of that skirt, some of the aft flaps, but Starship, again, was able to fight through it, make it all the way to that landing burn. We addressed that, changed some of our prop dump con-ups, though, so should not be seeing that this time around. And as a reminder, in addition to these missing tile tests, we're doing kind of a unique flight on the way in. It's going to do what we call a banking maneuver. So while we're still going supersonic and even hypersonic, we're doing kind of a banking turn. And then we'll do a pretty aggressive turn right as we get into the subsonic and start doing our belly flop. And that's designed to essentially be the approach that we would do on a return to launch site and a tower catch. So don't be surprised if we see the ship start to turn and make a few maneuvers as it makes its way down to the Indian. And fun fact, even though we're doing all this turning, we're essentially targeting the exact same spot in the Indian Ocean we went to last time. All right, just about 12 minutes to go. Still looking good. That gives a pretty good view of those aft flaps where, again, on the leading edge, I think it might be on the one on the other side, we had some tiles removed with no backups behind it. So again, we're really trying to stress some of the most sensitive areas around Starship, where basically if you lose a tile, it's the worst possible spot. And if we're able to make it through this, then that tells us quite a bit about just how resilient this vehicle is.
Yeah, and that shot we just had earlier was looking at what we call the business end of Starship with all the Raptor engines. And those are the engines that we're going to be expecting to light for that flip and landing burn, hopefully in about 10 minutes once we get through reentry. Yeah, there we go.
Yeah, looking at E3, that's the one we did the relight on. So it's 2 for 2 so far. We'll see if it can go 3 for 3.
Yeah.
All right, we can see that speed just continue to bleed off under 20,000 kilometers an hour. Ship's still holding together.
Yeah, and if you look in the bottom right, looks like we've made it all the way to the Indian Ocean. We're coming up kind of near Australia, the west side of Australia there, so pretty crazy. We're only 56 minutes in, and we've made it all the way, halfway around the world. It's actually a good demonstration of a future capability we hope to have on Starship, where we will do point-to-point transport on Earth. So essentially travel anywhere in the world in about an hour or so, which is going to be pretty crazy. Imagine going from New York to Sydney in 1 hour instead of the 20 hours it takes currently.
And a reminder, so this camera is, we see some of the heat rate picking up a little bit. And this camera is embedded right in the end of one of those forward flaps, so you see it moving around. That's the flap adjusting to maintain control. Looks like we're getting into our bank maneuver. Now power sliding through the atmosphere.
External temperatures are coming down. Vehicle is now at maximum dynamic pressure.
All right, that was basically our reverse max Q, so most aerodynamic stress that it's going to see during re-entry, we just passed through it, so we're past that, we're past peak heating. Ship's still holding together. So we're currently in this bank maneuver. We're gonna see it kind of roll over and do a pretty significant shift as we get down closer to the subsonic speeds.
Yeah, and that bank maneuver that Dan's mentioning is all in part of us to learn about the guidance, navigation, and control for return to launch site missions. So in the near future, we're hoping to return the ship back to the same pad we just took off on 59 minutes ago, and we've got to do some of these pretty dynamic bankings to make that trajectory work out.
All right, the light show kind of calming down as we're starting to move into the lower parts of the atmosphere. We should hit transonic, so hitting that transition between moving faster than the speed of sound and below the speed of sound in just about 3.5 minutes. Our landing burn should happen right around an hour and 6 minutes after launch, so we should be just about 6 minutes away from that. You can see lots of daylight. Everybody cross your fingers, see if our range team was able to get out there and provide any surprise views as Starship makes its way down. Oh, it's like they heard me. Ready and waiting, let's go.
Dan, you just spoke that view into existence there. And again, all brought to us by Starlink.
Maneuver has started.
All right, there we go. So we're now starting into our really heavy bank maneuver. Again, this does almost like a half circle loop to our actual trajectory. We're heading to the same exact splashdown point, but we're kind of doing a more roundabout way to get there, where it's this kind of big, long half moon loop and then a really aggressive and a twist right at the very end, and that would line us up with the launch tower. Starship, on a return to launch site, would fly over the tower, do a quick landing burn flip, and then come down for catching the arms.
How about that S38 decal there, staying strong on that view we just had?
Good to see the numbers back on.
Yeah.
All right, should be hitting transonic in about 2.5 minutes. Landing flip coming up in about 4. Pretty clouds there in the Indian Ocean today. Again, yeah, we changed our launch times. We launch in the evening now, so we get these daytime views down in the Indian Ocean. One of the things we're really looking for, the reason we have the drone, other than, yeah, that looks really cool, is we're able to kind of see the ship. We can only see so much from these cameras. You can't see like the vast majority of the heat shield. So we throw these buoys out there. We've got there's...
You spoke it again, Dan. There it is.
They're playing with me in the control room. All right. But we have these buoys out there. We have these drones that we're trying to see externally how the heat shield held up. Everybody saw from Flight 10 it had a little bit of a paint job, a little bit of a reddish hue. That was from those metallic tiles that we had tested, kind of oxidizing really rapidly in that plasma and then spreading those little oxide particles all over the heat shield. No metal tiles on this flight, so not expecting to see that.
Dynamic pressure is coming down.
Hope nobody gets seasick. All right, coming up on transonic shortly. It's about 2.5 minutes of landing burn.
Yeah, and once we get to around the 15-kilometer altitude mark, that's where we have a lot of flight history.
Starship is transonic, starting the belly flop phase of flight.
Yep, that belly flop phase that we perfected in the suborbital campaigns, we're entering that now.
Right, starting to get those Raptors ready. Should be 2 minutes away from landing burn. Again, we're going to do a flip. After we ignite those engines, we'll go from 3 down to 2 for the final phase of the landing burn and look for another soft splashdown, hopefully by our buoy and drone, which are hanging out, ready and waiting for a ship.
Seeing all 3 center engines have entered the chill phase.
All right, less than a minute to go.
The ship is making its turn for final approach.
And here's this kind of aggressive final turn that would essentially position it so it's right behind the launch and catch tower. Flaps holding strong. Landing burn in just under 20 seconds.
Ship landing startup.
There's our landing burn. Three down to 2.
Starship has landed.
As we said, we're not planning on recovering the ship today. Hey, welcome back to Earth, Starship.